Once we've discussed quartiles and how they break a data set into quarters, we can also discuss how that data value, each of those data values separates the lowest 25%, right? Q1. So if we identify where Q1 is, the lower quartile, right, separates out the lowest 25% of the data from the upper 75% of the data. And if we calculate the median, also called Q2, that separates the lowest 50% of the data from the upper 50%. And we can also talk about the upper quartile, Q3. And that separates out the lowest 75% of the data from the upper 25%. So we can say that Q1 represents the 25th percentile, and the median represents the 50th percentile, and then the upper quartile represents the 75th percentile. So when we say a number is the 25th percentile, we're saying that that number is greater than the lowest 25% of the data. The 75th percentile means that that data value is greater than 75% of the data below it. So with quartiles, we have the 25th percentile, 50th percentile, 75th percentile. Well, what if we wanted to know the 90th percentile? Could we do that? Or maybe we want the 10th percentile. Can we calculate that? The answer is yes. So there's a few different methods for doing this, but one of the methods is what we're going to see here next. Computing the data value corresponding to a given percentile. First thing you have to do is arrange the data in increasing order. Then you count the number of data values in the set and let that be represented by the variable n. If looking for the pth percentile, we're going to compute L is equal to P divided by 100 times n. Then, if that result is a whole number, then the pth percentile is the average of the data value in position L and in position L plus 1. But if L is not a whole number, we'll round that number up to the next whole number, and the pth percentile is the data value in that rounded up number position. So here's an example. Find the 40th percentile of the data set below: 22, 18, 13, 20, 19, 16, 17, 21, 11, 12, 14, and 15. And we have our 3 steps. So first step is to range the data in increasing order, which I've done here. So you'll notice that the values range from 11 all the way up to 22. Next, let n equal the number of data values in the set. So we have 1, 2, 3, all the way up to 12. So n equals 12. And we're looking for the pth percentile, the 40th percentile. So p is equal to 40. Therefore, we're going to calculate L is equal to P divided by 100 times n. So that's going to be 40 divided by 100 times 12. And if we compute that number, we get 4.8. Now 4.8 is not a whole number. So what do the directions say? We're going to round that up to the next whole number. So we're going to round that up to 5. And then we're going to look for the 5th number in our ordered list. So 1, 2, 3, 4, 5th one. And so 15 is the 40th percentile for this data set. Okay. Let's try another one. This time we're going to find the 90th percentile of a data set. 18, 13, 20, 19, 16, 17, 11, 12, 14, and 15. And we're going to follow our 3 steps. Step number 1, arrange the data in increasing order. So I have the lowest number is 12, and then we go all the way up to 20. This time we have 10 data values, so n is equal to 10. The 90th percentile, so p is equal to 90. And L is p divided by 100 times n. So that's going to be 90 divided by 100 times 10, which gives us the exact value of 9, which is a whole number. So we're going to look for that position and the next one up, 10th position. So we're going to look for the 9th and 10th values in the set in order. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we're going to take those 2 values and find their average, which is 19.5. So 19.5 is the 90th percentile. Okay. So that's if we're given the percentile and asked to find the value in the set. But what if the question was flipped? Asked you to tell me, okay, this data value in the set, what is its percentile? So we have a procedure for that. Again, it's 3 steps. Again, the first step is arrange the data in increasing order. Now we're going to let x be the value whose percentile is to be computed, and n is the number of values in the data set. Then the percentile of that number, the percentile of that number is equal to 100 times the number of values less than the one that we're considering, right? X is the number we're considering, plus 0.5, and then divide that by n. Here, all we then have to do is round the result to the nearest whole number. So here's a given set of data: 22, 18, 13, 20, 19, 16, 17, 21, 11, 12, 14, 15. And we're asked to find the percentile of the value 17 in the set. Okay. So following our steps, first step, arrange the data in order. So this is very similar to the first. We're just going to arrange them in order, right? 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So we have, again, 12 data values. So we need to write that down. N is equal to 12. And we're looking for the percentile of the number 17. So it tells us that we need to count the number of values less than 17. So 1, 2, 3, 4, 5, 6 values are less than 17. So the percentile is equal to 6 plus 0.5, right? The number of values less than that number we're considering, plus 0.5, and then divide that by n. So if we compute that up, we discover this is times 100. Whoops, sorry, forgot that. Hold on, let's back up. Times 100. So this is going to be 100 times 6.5 divided by 12. That result is 54.16 repeating. And so step 3 says all we have to do is round that to the nearest whole number. So here's the whole number part. So we take a look at the digit 1 to the right. It's less than 5, so we just drop the decimal. And this is the 54th percentile. So 17 is the 54th percentile.